We're still in the same section. Today we are going to start solving equations. So we got done graphing these exponentials, now we're going to solve equations. With these, we are going to be using a very important property. It says if a to the u equals a to the v, then u equals v. What that means, if I said like 2 to the x equals 2 to the 4th. Well, since the base is the same, the only way those things would be equal is if your exponents are equal. So if 2 to the x is equal to 2 to the 4th, then x has to be 4. So what we can do, if we can get the same base on each side of our equation, we can actually drop that base and set the exponents equal. But it has to be exactly like this. We can only have the base written once on each side. I can't have like 2 to the x times 2 to the 4th. It has to be once on each side, and then we are able to set your exponents equal. So we are going to just jump in with a problem. So let's just start here. So 3 to the x plus 1 equals 81. All right, we need to get the same base on each side. Now 3, I can't really break down, so that just has to stay. But what could I change 81 to?
3 cubed. Or to the 4th.
3 to the 4th. It is 9 squared, but my goal is to get the same base as the other side. So my question is, can I write it as 3 to some power? And we can't. It's equal to 3 to the 4th. So now, if the base is the same on each side, you can drop that base and just say the exponents are equal. X plus 1 has to equal 4. Subtract your 1 and x is 3. And we can always check these. If you plug in your 3, 3 plus 1 is 4, 3 to the 4th does equal 81. All right, so B. What would I do?
Put negative x equal to 1.
Well, we want the common base. So then negative x equals 4. So x is negative 4. Okay. What if I gave you 1/5 to the x plus 3 power equals 25.
Could we flip 1/5?
Yeah, we can flip one. If you flip 1/5, you want to write it as a 5 to what power would flip it? A -1. Okay, so what do you have to do with these exponents? So that's 5 to the negative x minus 3. How would you rewrite 25?
5 squared.
So then our exponents are equal. So if we add the 3, it's -5. Check it real quick. Grab your calculator. Put 1/5 in parentheses. And then your exponent is -5 plus 3. Does it work out?
Yes.
Let's do this one. Okay. What can we do here? Eight times 2 is 16, but does that help me? No. 16 is 4 squared. Is that helpful? No, because 8 isn't a power of 4. Okay, 8 is 2 to the 3rd. So I'm changing that h to the 3rd. And that's all to the x plus 14 power. 16 is 2 to the 4th. So then if we distribute, we get 2 to the -3x plus 42 equals 2 to the 4x. So now we have the same base on each side, so now the exponents are equal. If I add over my 3x, divide by 7, and we get 6. Okay, you can always check this just by plugging it into the original. Let's try this one. Okay. Can you break down 3 at all?
No.
No. So that has to stay. What about 27?
3 to the 3rd.
So on the left, nothing changes. On the right, power to a power you multiply, so that's 3 to the 6x. So then we can set those exponents equal to one another. We subtract over the 6x. Multiply to -7 and add to -6. So if you set those equal to 0, we get x to be
7, 1.
So So it's possible to have more than one answer. If you are checking these, they will both work. We're not going to get answers that don't work unless we make a mistake along the way.
So you want us to check it every time?
I would suggest it just, like, especially on a test, I would check them just to make sure you got it, but. Let's do this one.
Yes.
Can I multiply this 4 and the 2?
No.
No. Order of operations says you have to do exponents before you multiply. So instead, what could I do with this 4?
2 squared.
Whoops. Not 4 squared. So 4 is the same as 2 to the second. We still have the 2x squared. 16 is the same as,
2 to the 4th.
and that had a square on it. So we get 2 to the 2x times 2 to the x squared equals 2 to the 8th. Can I drop my base yet?
Yeah.
Because you still
Oh, yeah, you have to multiply this
Yes.
first.
When you multiply these, the base doesn't change. What do you do with your exponent?
add.
Add them. So that becomes 2.
X squared.
Mhm. So then you can set those exponents equal to one another. Subtract over the 8. What multiplies to -8 and adds to +2?
4.
So x equals -4 and +2. How are we doing with this?
Easy.
Good. So let's do just a couple more, make sure we've got it. Okay, the E doesn't change anything. E is just kind of like pi. It has a set value. It's just a number. So what can we do here?
You did that with 1 over e squared to the top.
Right. If I want to bring that to the top, what would I have to do to my exponent? Mm-hmm. So then, since those e's are multiplied, you can add your exponents. And then if you have the same base on each side, you can drop it. We always set quadratics equal to 0. So what would this factor into?
2, 1.
You want a hard one?
Yes, I think he's all. Yes, sir.
How about I give you
What would you do? Oh, hey. Oh. I don't think she's gonna get out. She's just gonna say, yeah, I'm saying reactions. I don't think they're sure. No.
Okay. Any ideas?
You can turn that into a fraction.
So the cube root of 7 is 7 to the 1/3. So that's 7 to the negative 1/3 x. I need the same base. What can I change 1 to? What do I need my base to be?
7.
We need it to be 7. Does 7 to some power equal 1?
0.
Anything to the 0 power is 1. So then negative 1/3 x equals 0. Divide by negative 1/3, and x is 0.